Friends, myself Dattatreya Jadhav. I am from HM College Karad. In previous videos, we have learned about integration by partial fraction. There are three types of integration by partial fraction. First one is denominator contains non-repeated linear factor. Second one is denominator contains repeated linear factor. And third one is denominator contains irreducible quadratic equation. In today's lecture, we learn about this third type. Denominator contains irreducible quadratic equation. Okay, irreducible quadratic equation. So the fraction is as p of x divided by q of x is equal to p of x numerator whatever may be, but denominator contains irreducible quadratic equation. It means that the equation x square plus bx plus c is there. Okay, one equation or two equations are there in denominator which are non-reducible, that is irreducible. For example, I can write here p of x divided by x square plus 1. Look at this quadratic equation, x square plus 1 cannot be factorized. So its corresponding partial fraction can be written as, since degree of x square is 2, there are two constants. First one is a, second one is b, and in numerator write ax plus b. For denominator contains irreducible quadratic equation. Divided by denominator as b. It's our corresponding partial fraction of this example, p of x divided by x square plus 1. If there are two quadratic equations such as p of x divided by x square plus bx plus c into dx square plus ex plus f, then we can write its corresponding factor as, since degree of denominator is 4, there are four constants. First one is x plus b divided by first quadratic equation, x square plus bx plus c plus cx plus d into divided by second quadratic equation, dx square plus ex plus f. Means we here seen that if there is a two quadratic equations in denominator which are irreducible, then its corresponding fraction, partial fraction is of the form ax plus b divided by x square plus bx plus c plus cx plus d divided by dx square plus ex plus f. For quadratic term, the numerator must be ax in the form of ax plus b. So today we are going to discuss some example of denominator contains irreducible quadratic equation. First example is evaluate the integration of 3x plus 2x plus 3. Evaluate integration of 2x plus 3 divided by 3x plus 2 into x square plus 1 dx. Okay, evaluate integration of 2x plus 3 divided by 3x plus 2 into x square plus 1 dx. Yes, first it is a clearly example on integration, so denote this integration by I. So starting with let I is equal to. Now here example is of algebraic integration. Example is of algebraic integration. Look at numerator 2x plus 3. It's a linear equation. And in denominator there are two terms. First one is 3x plus 2, which is a linear equation, and second one is x square plus 1, that is a quadratic equation. Means denominator contains non-repeated linear factor, also a quadratic equation. So we solve this integration by partial fraction. By partial fraction. So consider the fraction in the example. Consider fraction in the example. Here fraction is 2x plus 3 divided by 3x plus 2 into x square plus 1, which is equal to, here since there is a non-repeated linear factor is there, so its corresponding partial fraction can be written as a divided by 3x plus 2. Since there are, yes, degree of denominator is 3, there are 3 constants. So here is first one, a divided by 3x plus 2, plus for this factor denominator contains irreducible quadratic equation. This equation x square plus 1 cannot be reduced right here, so I can write its corresponding partial fraction as bx plus c divided by x square plus 1, which is our equation number first, where a, b, c are constants and which are we find. So making denominator same on RHS or taking LCM on RHS, it's 3x plus 2 into x square plus 1 multiplied a by x square plus 1, so x square plus 1 into a plus bx plus c into 3x plus 2, and here is LHS 2x plus 3 divided by 3x plus 2 into x square plus 1. Here denominator in both the sides are same, so cancelling that denominator, so we get this denominator get cancelled, we get equation 2x plus 3 is equal to x square plus 1 into a plus bx plus c into 3x plus 2. It's our equation number second. Equation second is true for all values of x. Equation second is true for all values of x, but we put the appropriate values for x. So we get the values of a, b and c. Put x is equal to, for look at here, to find the value of a, make coefficient of that term is 0. Coefficient of bx plus c is 0. Coefficient of bx plus c is 3x plus 2. 3x plus 2 is 0 when 3x is equal to minus 2. It means that x is equal to minus 2 divided by 3. When x is equal to minus 2 divided by 3, that term becomes 0. There is only term of a, and we can easily calculate the value of a. So putting x is equal to minus 2 divided by 3 in equation number second. So equation second becomes 2 into minus 2 divided by 3 plus 3 is equal to minus 2 divided by 3 square plus 1 into a. And here when we put x is equal to minus 2 by 3, 3 get cancelled, it's minus 2 plus 2, it becomes 0, then whole the term is 0, so forget about that term. Minus 4 divided by 3 plus 3 is equal to minus 2 divided by 3 square is 4 divided by 9 plus 1 into a. Solving 3 3s are 9, 9 minus 4 is 5, 5 divided by 3, 9 1 is 9, 9 plus 4, 13, 13 divided by 9, a. 3 3s are 9, 3 5s are 15, 15 divided by 13 is the value of a, 15 divided by 13. Here we easily calculate value of a, but when we here we find another values for b and c. For that, put x is equal to, look at here, when we put x is equal to 0 here, the term of b is 0. So we get equation in a and c. We get equation in a and c, but value of a is no. Therefore, we get here value of c. So put x is equal to 0 in equation 2. 2 into 0 plus 3, that is 3 is equal to 0 square is 0 plus 1, 1 into a is a plus b into 0 is 0 plus c. and here 3 into 0 is 0 plus 2, 2, so c into 2. Therefore 2c is equal to, I can write 2c is equal to 3 minus a, that is equal to 3 minus value of a is 15 divided by 13, which is equal to, yes sir, 13 3s are 39 minus 15, it's clearly 24 divided by 13. 2c is equal to 24 divided by 13, 2 12s are 24, therefore c is equal to 12 divided by 13. Here we get value of c. Now for finding the value of b, put any value of x, whatever you want. But for simplification, I put here 1. Put x is equal to 1 in equation number 2. Yes, here 2 into 1 is 2, 2 plus 3 is clearly equal to 5 is equal to 1 square is 1 plus 1, that is 1 square is 1 plus 1, 2a plus b into 1 is b, b plus c as it is, into 3 into 1, 3, 3 plus 2 is 5. After solving this equation, we get equation in a, b and c, and in which a and c is already known. We find easily value of b. So therefore 5 is equal to 2a plus 5b plus 5c on multiplying by 5. But we have to find the value of b, so writing this equation for b, 5b is equal to 5 minus 2a minus 5c, which is equal to 5 minus 2 into value of a is, look at here, a is 15 by 13. 15 by 13 minus 5 into value of c is here 12 by 13, 12 divided by 13. On simplification, I can write here 5 as it is, minus 2 15s are 30 divided by 30, minus 5 12s are 60 divided by 30. Making denominator same here, denominator is 13. So I can write this as 13 5s are 65 minus 30 minus 60. 65 minus 30 is 5, minus 30 plus 5 is 20, minus 25 divided by 30. It's value of 5b. From this we get value of b. b is what? So 5 5s are 25. So b is what? Minus 5 divided by 30. Here we get the values of a, b and c. Therefore, I can write equation 1 as, therefore, equation 1 becomes, what we write about equation 1? LHS is 2x plus 3 divided by, denominator is 3x plus 2 into x square plus 1 is equal to a. What is a? It's 15 divided by 13 divided by x square 3x plus 2 plus, well, bx, that is value of b is here minus 5 divided by 13 into x plus c. C is here 12 divided by 13 divided by x square plus 1. Okay, so we have to find the integration of 2x plus 3 divided by 3x plus 2 into x square plus 1. That is this term. That is this term. So it is more convenient to take integration of that term. So I is equal to, I can be written as integration of 15 divided by, we know that denominator of numerator is always comes in denominator, 15 divided by 13 into 3x plus 2 plus minus 5 divided by 13x plus 12 divided by 13 divided by x square plus 1 dx. On separating integration here, I can write this as, I is equal to integration of 15 divided by 13 into 3x plus 2, okay, plus minus separating denominator here, minus 5 divided by 13 into x square plus 1 plus 12 divided by 13, I can write here plus 12 divided by 13 into x square plus 1 dx. Inside the integration there is addition, subtraction. Here is x. Inside the integration there is addition and subtraction. So we can separate integration sign and taking constant outside the integration. 15 divided by 13 is constant. So take outside the integration. It's integration of 1 upon 3x plus 2 dx minus 5 divided by 13 is again constants. It's integration of x divided by x square plus 1 dx plus 12 divided by 13 is again a constant. Take outside the integration of 1 upon x square plus 1 dx, which is equal to 15 divided by 13 into integration of 1 upon 3x plus 2 dx minus 5 divided by 13 into, look at here, derivative of x square is 2x. So adjacent 2, we multiply by 2 and divide by 2. So it becomes 5 divided by 13 into 1 upon 2 into integration of 2x divided by x square plus 1 dx plus 12 divided by 13 into integration of 1 upon x square plus 1 dx. So final answer is 15 divided by 13 as it is. 15 divided by 13 as it is into integration of 1 upon 3x plus 2 is log of mod of 3x plus 2 divided by 3 plus, sorry, minus is here, 13 2s are, yes, 26 minus 5 divided by 26 into derivative of denominator is numerator, so I can write this as log of mod of denominator x square plus 1 plus 12 divided by 13 into, yes, integration of 1 upon x square plus 1 is its tan inverse is 12 divided by 13 into tan inverse x plus constant of integration c. 3 5s are 15, 3 5s are 15, so final answer is 5 divided by 30 into log of mod of 3x plus 2 minus 5 divided by 26 into log of mod of x square plus 1 plus 12 divided by 13 into tan inverse x plus constant of integration c. Here is the final answer of the given question. Now we see one more example on this type. Example is evaluate integration of, in numerator there is a 5 e raised to x, in numerator there is a term 5 e raised to x, and in denominator the terms are 5 e raised to x divided by, in denominator it's e raised to x plus 1, e raised to x plus 1 into e raised to 2x plus 1 dx. Evaluate integration of 5 e raised to x into divided by e raised to x plus 1 into e raised to 2x plus 1. Sorry, here is the term 9, not 1, it's 9 dx. Now look at here, in this example it is clearly seen that the derivative of e raised to x is again e raised to x, so we substitute for the term e raised to x. So put, first denote the given integration by I. So I is equal to integration of 5 e raised to x divided by e raised to x plus 1 into e raised to 2x plus 9 dx. So put, when we put e raised to x is equal to t, on differentiating we write this as e raised to x into dx is equal to dt. So integration becomes I is equal to, that term is nothing but e raised to x dx dt, 5 dt divided by e raised to x is t, so it's t plus 1 into, here is the term e raised to 2x. E raised to 2x can be written as e raised to x square. E raised to 2x can be written as e raised to x square by law of indices. So I can write this as e raised to x is t, so I can write this as t square plus 9. Okay. So look at denominator carefully. Denominator contains one linear equation and one irreducible quadratic equation, because t square plus 9 cannot be factorized. So we solve this integration by which method? Partial fraction. By partial fraction, consider the fraction inside the integration. Therefore we consider here 5 divided by t plus 1 into t square plus 9 is equal to, yes, here is a linear equation, so its corresponding factor is a divided by t plus 1 from our type first, and here is quadratic equation. So for quadratic equation, in numerator there is term bt plus c divided by t square plus 9, which is our equation number first. Now here a, b, c are constants which are to be determined here. So for determination of a, b, c, we take LCM on RHS. So RHS becomes its t plus 1 into t square plus 9 multiplied a by t square plus 9 and bt plus c by t plus 1, and cancelling the denominator from both the sides, that is t plus 1 into t square plus 9. Therefore we get a equation 5 is equal to t square plus 9 into a, here is a, plus bt plus c into t plus 1, which is equation number second. Equation second is true for all values of t, but we put appropriate values for t for getting the values of a, b and c. First I can put here t is equal to, for finding the value of a, look at here, the coefficient of the term bt plus c is t plus 1, making that t plus 1 as a 0. T plus 1 is equal to 0, it means that t is equal to minus 1. So put t is equal to minus 1, we get in equation number second 5 is equal to, put t is equal to 1, 1 square is 1, 1 plus 9 is 10 into a, plus when we put t is equal to minus 1 here, when we put t is equal to minus 1 here, plus 1 minus 1 get cancelled, it's 0, 0 into that term is 0. So forget about the term bt plus c into t plus 1. From this equation we say that a is equal to 1 upon 2. A is equal to 1 upon 2. Now for finding another value, put t is equal to, yes, if we put here t is equal to 0, then b is 0. We get equation in terms of a and c. We get a equation in terms of a and c, and in which value of a is known, we easily calculate the value of c. So put t is equal to 0. Why we put t is equal to 0? Because here one constant is eliminated. That's it. So RHS is 5 is equal to, when we put t is equal to 0, 0 square is 0 plus 9, 9 into a is 9a. Here t is 0, b into 0 is 0 plus c, that is c into t is equal to 0, 0 plus 1, 1, c into 1 is c. From this equation, we find the value of c. C can be written as 5 minus 9a, which is equal to 5 minus 9 into value of a is 1 upon 2. So 5 minus 9 divided by 2, which is equal to 10 minus 9. It's 1 upon 2. So here is the value of c. C is 1 upon 2. Put t is equal to any value. Put t is equal to any value other than this minus 1 and 0. For easy calculation, I can put here t is equal to 1. So equation second becomes, when we put t is equal to 1 in equation second, LHS is 5 is equal to 1 square is 1, 1 plus 9 is 10, 10 into a is 10a. When we put t is equal to 1, 1 into b is b, b plus c into, when t is equal to 1, 1 plus 1 is 2. Therefore, 5 is equal to 10a plus 2b plus 2c. Here we get an equation in terms of a, b and c, in which value of a is known and value of c is known. To find value of b, I can write this equation for 2b. 2b is equal to 5 minus 10a minus 2c, which is equal to 5 minus 10 into value of a is 1 upon 2. So 10 into 1 upon 2 is 10 by 2, minus 2 into value of c is 1 upon 2. 1 upon 2, 2 into 1 upon 2 is 2 upon 2. 5 minus 10 divided by 2 is 5. Minus 2 divided by 2 is 1. 5 minus 5 is 0, minus 1. 2b is equal to minus 1. This implies b is equal to minus half. Here we find all the constants a, b and c. So now equation first becomes 5 divided by t plus 1 into t square plus 9, which is equal to a divided by a is what? Here 1 upon 2 divided by t plus 1 plus bt plus c. b is here minus 1 upon 2 into t plus c. c is half divided by t square plus 9. We have to find the integration of 5 divided by t plus 1 into t square plus 9, replacing that term by that term, since it is more convenient to find integration of RHS. So I is equal to, replacing that term by that term, integration becomes 1 upon 2 into t plus 1, since denominator of numerator comes in denominator, plus minus 1 upon 2 into t plus 1 upon 2 divided by t square plus 9 into dt. On separating denominator, here we get 1 upon integration of 1 upon 2 into t plus 1 plus minus minus, and denominator of numerator comes in denominator, so minus 1 upon 2 into t divided by t square plus 9 plus 1 upon 2 into t square plus 9 dt. Inside the integration there is addition. We separate integration sign with dt symbol and taking constants outside the integration. So integration becomes I is equal to, here 1 upon 2 is constant, so take outside the integration 1 upon 2 into integration of 1 upon t plus 1 dt. Minus 1 upon 2 is again a constant, so take outside the integration 1 upon 2 into integration of t divided by t square plus 9 dt, plus 1 upon 2 is constant, 1 upon 2 into integration of 1 upon t t square plus 9 dt, which is equal to 1 upon 2 into integration of 1 upon t plus 1 as it is minus 1 upon 2 into adjusting the derivative of denominator in numerator. Here derivative of t square plus 9 is 2t, so adjusting the term 2. So when we multiply 2 inside the integration and divide by 2 outside the integration, dt plus 1 upon 2 into integration of this can be written as t square plus 3 square dt, which is equal to 1 upon 2 into log of mod of t plus 1 minus 1 upon 4 into log of mod of denominator t square plus 9, since derivative of denominator is in numerator, plus 1 upon 2 into integration of 1 upon x square plus a square. 1 upon a, tan inverse of x upon a. So 1 upon a is 3 into tan inverse t by 3 plus constant of integration c, which is equal to 1 upon 2 into log of mod of t plus 1 minus 1 upon 4 into, I can write this as 1 upon 4 as 2 into 2 and 1 upon 2 log m is log of m raised to 1 upon 2 minus 1 upon 2 into, by using n log m, it's log of m raised to n. I can write this as log of t square plus 9 bracket raised to half plus 2 into 3 6, 1 upon 6 into tan inverse t divided by 3 plus c. I can write here so final answer is as I is equal to I is equal to 1 upon 2. Look at here, 1 upon 2 taking 1 upon 2 common, log of mod of t plus 1 minus t square log of t square plus 9 bracket raised to half, that is I can put here square root for that term, root of t square plus 9 plus 1 upon 6 into tan inverse t divided by 3 plus c. Therefore 1 upon 2 into log of mod of its t plus 1 divided by square root of t square plus 9, since log n minus log n is log m upon n, so log of t plus 1 divided by square root of t square plus 9 plus 1 upon 6 into tan inverse of t by 3 plus constant of integration c, 1 upon 2 as it is into log of mod of, since answer is in variable t but question is in variable x because of our substitution, so resubstitute the value of t as e raised to x, so answer is 1 upon 2 into log of mod of e raised to x plus 1 divided by square root of e raised to x square, that is e raised to 2x plus 9 plus 1 upon 6 into tan inverse of t by t is what, e raised to x divided by 3 plus constant of integration c. This is the final answer of the given integration. You solve one example for homework. It's evaluate integration of 2 log x plus 3 divided by 2 log x plus 3 divided by 3 log x plus 2 3 log x plus 2 into log of x bracket square plus 1 log of x bracket square plus 1 dx, and here is the term x. I can repeat question here again. Evaluate integration 2 log x plus 3 divided by x into 3 log x plus 2 into log of x bracket square plus 1, which is much similar to first example. When we substitute for log x is equal to t, we get 1 upon x dx is equal to dt, and after substitution given equation can be reduces, given integration can be reduces to our first example, which is in variable t, and solve for that. So I hope you learn all these examples from today's lecture. Thank you for watching the video.